Hello, I'm Simon Whistler. You're watching the Today I Found Our YouTube channel, and in the video today we're looking at why cans of Diet Coke float and cans of regular Coke don't. So it's a fun fact that if you put a can of Coca-Cola into a pool of water, it will sink. However, if you put a can of Diet Coke into the same pool, it will float. Another fun fact, by the way, is that Coca-Cola was invented by a man seeking a cure for morphine addiction that he acquired during the Civil War, and he marketed Coca-Cola as that cure. In any event, initially, this floating problem may seem an odd one because both cans are exactly the same size and contain exactly the same amount of liquid. Of course, anyone who's ever taken a physics class at some point probably knows what makes a given object float in the first place. In the simplest possible sense, this is that an object will float provided it displaces an amount of liquid or sufficiently dense gas that weighs more than itself. As you may recall, one of the earliest known scientific uses of density was by the ancient Greek mathematician and all-round nerd Archimedes, when the king of Syracuse supposedly asked him to determine whether or not his crown was made from the same bar of pure gold he'd originally given his jeweler. The king suspected that the jeweler had pocketed some of the gold he had been given, replacing it with silver, but he couldn't prove it without melting down the crown and physically comparing it to another block of gold the same size as the original, which wasn't an option the king was going to consider. Eventually, Archimedes hatched a cunning plan to submerge the crown and measure the amount of water it displaced, and compare that to the amount of water displaced by an equal mass of pure gold. If the crown had been made with less dense materials than pure gold, including silver, it would displace more water than the gold bar. Legend has it that Archimedes happened upon this idea when he jumped into a bath full of water and sent waves of bath water cascading to the floor, resulting in him running naked through the streets, screaming "Eureka!", which is Greek for "I found it!". Sadly, but perhaps not surprisingly, both Archimedes' Eureka moment and the whole idea of him submerging the crown in water are believed to be the work of fiction, attributed to noted Roman scholar Vitruvius a full 2 centuries after Archimedes died. Further, it's believed that simply submerging the crown in water wouldn't have given precise enough measurements for Archimedes to make a judgment on whether or not the crown contained a little silver, at least not with the tools he had available. But it does make for a great anecdote to tell high school students, I suppose. Another common one told by many a math teacher or professor is that the reason there is no Nobel Prize for mathematics is because a famed mathematician stole Alfred Nobel's girl. Unfortunately for those same high school instructors, this is not true at all either. We've got more on that in an upcoming video. In any event, regarding the veracity of such tales, Archimedes' name ultimately would be forever linked with the idea of density and buoyancy after he wrote the following in his landmark piece on floating bodies. If a solid lighter than a fluid is forcibly immersed in it, the solid will be driven upwards by a force equal to the difference between its weight and the weight of the fluid displaced. Today, this idea is, of course, known as Archimedes' principle. Alright, so getting back to the cans of floating fizzy drinks. We know from all this that given a can of Diet Coke floats and a regular can of Coke sinks, despite the pair containing the same amount of liquid and in the same model of can, the regular Coke's combined ingredients must be more dense. And in fact, a 12-ounce can of Coke has more mass because of the 39 grams of sugar it contains compared to the 125 milligrams of sweetener in a can of Diet Coke. The minute difference in density between both cans just so happens to result in the total mass of either can falling on either side of the average density of pure water, just slightly less than 1 gram per cc, varying slightly based on temperature, reaching its maximum density at about 4 degrees Celsius or 39.2 degrees Fahrenheit. This all results in one can floating and the other sinking, and science teachers everywhere having a trick to show along with their often questionably accurate anecdotes. And now for a bonus fact. A better method Archimedes could have used with technology available in his day, which wouldn't have required extreme precision to solve the supposed crown problem, was later suggested by Galileo Galilei, namely compare the dry weight and the wet weight. More specifically, first balance the crown and the lump of gold on a scale in air. Next, do the same, but when submersed in water. If they don't balance the same, one contains something that the other doesn't. And now for another bonus fact. Another common science classroom anecdote is that Newton had an apple fall on his head, which inspired his so-called Eureka moment on how gravity worked. Surprisingly enough, this does have some truth to it, and you can see more on that in our video, Did Newton Really Have an Apple Fall on His Head? So I really hope you found that video interesting. If you did, please do hit that thumbs up button below, and don't forget to subscribe if you haven't already for brand new videos just like this every day of the week. Also, over there on the right, a couple of other videos that you might enjoy if you enjoyed this one, and thank you for watching.